All right, we saved the best for last, identifying the domain and the range of a quadratic function. Well, as you can see by what I've already written here, it's a little more complicated to identify the range than it is to identify the domain. I do want to let you know that I've written out a lot here under how to identify the range, but just know that it's actually a lot easier than all these words make it appear. Once you do this a few times, I think it'll become really, really easy. And it's actually a lot easier to identify the range of a quadratic function if you're looking at its graph. But you can't always look at its graph, like maybe you can't, like on a test or something. So you're going to want to practice this procedure a lot. So let's say we have this situation. It says, what is the domain and range of the function f of x negative x squared minus 5? There's our function, negative x squared minus 5. That is a quadratic function, okay, because it has an x squared, okay? Now, you might say, well, it doesn't look usual, like I'm used to seeing like plus 5, 7x and then minus 5. Well, in this case, the b is just equal to 0, okay? This would be the equivalent of negative x squared plus 0x minus 5. This is the same thing, only 0 times x is 0, and plus 0 minus 5 just means minus 5. So this is the same thing as this, but the b is equal to 0. We're going to want to remember that the b is equal to 0 when we get to step 2 here, when we need to identify what b is, okay? All right, so the first thing I want you to know is that the domain of a quadratic function is very easy. It's negative infinity to positive infinity. You can plug any real number into any quadratic equation, okay? Just like a linear function, just like a cubic function. All polynomial functions, actually, you can plug any number into all polynomial functions, okay? But now let's talk about the range. So I already know that the domain of this, it says what is the domain and range of this quadratic function? Well, I'm going to do domain is negative infinity up to positive infinity. That was easy. Now I want to identify the range, and the range is going to take a bit of work. We're going to go through these 4 steps, okay? Now, if you'll notice here, we have an either or. So step 1 is to identify whether your function has a minimum or a maximum. All quadratic functions have either a minimum point or a maximum point. And it depends on whether they are what's called an upward parabola, a U-shaped. I call this up like a cup. Or it's a smile, right? It's a smile. Or the other way is down like a frown. So sometimes a parabola might be flipped upside down, and so I say down like a frown. So a quadratic, the graph, the parabola, can be up like a cup or down like a frown. Well, if it's up like a cup, then this point right here, that's called the minimum point. That is the minimum, min, okay? And so all of the values on the graph are larger than that number, okay? So this is the lowest point, and then all the other points are above the lowest point, okay? This point right here is, if it's down like a frown, it has a maximum point. That's the highest point. We're going to put max, okay? So that is the highest point of the graph, and all other points on the graph are lower, are below the highest point, which is the max, okay? And so the first thing we have to do is we have to identify whether our quadratic, whether we're dealing with a minimum or are we dealing with a maximum. Well, I can tell you it's going to be a minimum if the a value is greater than 0, meaning if it's positive. If on the front of your x squared there's no negative, if it's a positive x squared, then you're going to have a minimum. But if your a is less than 0 or negative, if your x squared starts with a negative, then you're going to have a maximum. So you can see here, this function is negative x squared minus 5. Therefore, this quadratic is going to have a maximum, not a minimum. Okay? All right, so I finished step 1. Identify whether it has a minimum or maximum. This one has a maximum. So step 1, this one has a maximum. Okay? Step 2, identify x sub v. Well, x sub v means the vertex x value. V stands for vertex. That point, that maximum point or minimum point, is called the vertex of the parabola. Okay? And so we want to identify the x value of the vertex. And the way you identify that is you take the a and the b from the quadratic expression. And you know what a, b, and c are because you did the quadratic formula. And what you're going to do is you're going to do negative b over 2a. Well, in this case, b is 0. We already said that before. So we're going to identify x sub b, or x sub v, that's going to be negative 0. By the way, negative 0 is just 0, okay? So negative 0, so 0 over 2 times a. And in this case, what is a? A is negative 1. The x squared, what's in front of the x squared? A negative, but when we don't put a number there, we know it's a 1. So the number, the coefficient of x squared is negative 1. So this is going to be 2 times negative 1, and here's what we come up with. 0 over negative 2, and 0 divided by anything that's not 0 is equal to 0. And so we know that our vertex x value is 0, okay? So we've just finished, and it's a maximum point. So step 3 says, plug that number that you just got in step 2, plug x sub v into the quadratic function for x. So I want to identify f of x sub v. Well, x sub v is 0, so I want to identify f of 0. I plug it in, so I got to put a 0 here for x. So I'll have negative 0 squared minus 5. Well, 0 squared is 0, and negative 0 is 0. And 0 minus 5 is negative 5. So that's negative 5. So I know that f of 0 is negative 5. So that's an important number. That's actually going to now be a part of our range, okay? And then step 4 says, if it's a minimum, we don't have a minimum, we have a maximum. So it says if it's a maximum, then the range is going to be negative infinity up to that number you just got. So for us, f of 0, or f of x sub v, is negative 5. So our range is going to be negative infinity to negative 5. So our range is negative infinity up to negative 5, and we're done. I'll bet you'd probably want to see at least 1 or 2 more examples now. Okay, here's another example. What is the domain and range of f of x is x squared plus 7? It's a quadratic because we have an x squared. We can see here that the coefficient of x squared is a positive 1. So a is positive 1. In fact, we can note this here. A is 1. There's no middle term. There's no b, and therefore b is 0, and c is 7. But we don't really need 7, but we'll put it on there anyway. C is positive 7. So we know that the domain of all quadratic functions is negative infinity to positive infinity, so now we just need to get the range. It says identify this function as having a minimum or a maximum. Well, since a is a positive number, we know that this one has a minimum. Right? So step 1, we know this one's going to have a minimum point. And down here, step 4, that means that our range is going to be bracket, number, comma, infinity. So we know that our range right now is going to be bracket, we're going to leave some space for a number, and it's going to go up to infinity. So we're almost done. Now we just need to know what number to put here. Well, we're going to find that in step 2 and step 3. Step 2 says, identify negative b over 2a. That's our x sub v. That's the x value at the minimum point. Okay, so x sub v is negative b. Well, b is 0. So it's negative 0 over 2 times a. A is 1, so that's 2 times 1. And so negative 0 is just 0. So we have 0 over 2 times 1, which is 2. 0 over 2, which is 0, just like the last question we did. Okay. Now what we're going to do is we're going to plug the 0 into the quadratic function for step 3. Here's our quadratic function, f of 0. So f of 0 is 0 squared plus 7. Is equal to 0 squared plus 7. Well, 0 times 0 is 0, and 0 plus 7 is 7. And therefore, our number is 7. And that number is going to go right here, and we're done. The range is 7 up to infinity. Let's just do one more example. Okay, here's our last example. What's the domain and range of the function f of x is equal to negative 2x squared minus 12x minus 17? Okay? And so we know that the domain of all quadratic functions is negative infinity to positive infinity. That's not going to change. Now we just need to do the range. Now we can see that a, so let's go ahead and identify a, b, and c. A is negative 2. B is negative 12. and c is negative 17. Now we actually don't need c. I'm just, we can identify it. We don't need it to find the range. We just need a and b. But you can see, step 1, identify f of x as having a minimum if a is positive. Well, a is negative. It's negative 2. That means that this function has a maximum because a is negative. So we know that this is going to have a maximum value. And if we go down to step 4, we can say that if it has a maximum, then the range is going to go from negative infinity up to the number that we calculate at the maximum. Okay? And so we're going to go ahead and write that in. The range is going to be negative infinity up to some number. I'll leave a space and put a bracket. It's always a bracket. Now we're going to do step 2, which is identify the x value at the vertex, which is calculated by negative b over 2a. So x sub v in this case is negative b. That's negative 12. Because b is negative 12. We got to have both of we got to have the negative from the formula and the negative from the b. And then over 2 times a. Well, a is negative 2. Well, negative 12 is not negative 12, so it must be positive 12. So that's 12 over 2 times negative 2 is negative 4. And 12 divided by negative 4 is negative 3, because a positive divided by a negative is a negative. And so x sub v is negative 3. And so in step 3, we want to plug negative 3 into the function. I want to plug negative 3 in right here. So we're going to put a negative 3 here, and we're going to put a negative 3 here. So we're going to get, we're going to get negative 2 times negative 3 squared minus 12 times negative 3 minus, that's a negative, minus 17. Okay? All right, well, let's work this out. So that means that f of negative 3 squared, that's negative 3 times negative 3. That's positive 9. Positive 9 times negative 2, that's negative 18. Negative 12 times negative 3 is positive 36. So I'll put plus 36 minus 17. Minus 17. You might need a calculator for this. I don't, but you may. Negative 18 plus 36 is positive 18. Positive 18. And positive 18 minus 17 is 1. And therefore, f of negative 3, the output is positive 1, and that is the number that goes in our range. And therefore, the range of this function is from negative infinity up to 1. And that is how you identify the domain and the range of a quadratic function.